Think about it. Every single day, we trust companies with our most valuable information. Our emails, our photos, our financial details, you name it. All of that stuff gets stored in these vast databases, which really are like massive digital fortresses.
So, the big question is, how do they actually protect that fortress? Because believe me, it is a constant battle. And the answer, well, it all comes down to the core principles of database security. Let's dive in and see what those are.
All right, here's our game plan. We're going to take a tour of that fortress. We'll start by figuring out what the crown jewels are, then we'll look at the digital defenses, see who gets the keys, and finally, we'll connect it all back to why this is so crucial for our privacy. Okay, first stop, the fortress itself. You got to understand that database security isn't just one single thing. It's a huge, sprawling field that covers everything from company policy all the way down to the nitty-gritty code that makes the whole system run. Now, before you can defend a fortress, you have to know what you're protecting, right? In the world of information, the treasure, our crown jewels, is the data, and protecting that data really rests on three fundamental pillars. And this is where something called the CIA triad comes in: confidentiality, integrity, and availability. These are like the three non-negotiable goals for any security system. Seriously, if even one of these fails, the whole fortress is in trouble.
First up, confidentiality. And yeah, it's pretty much exactly what it sounds like. Keeping secrets secret. The whole point here is to stop information from getting into the wrong hands. You can think of it like putting up a massive shield to block a hacker's prying eyes. Next is integrity. This one is all about trust. It's about making absolutely sure that your data is accurate and hasn't been messed with. I mean, just imagine if someone could secretly change your bank account balance or alter a medical record. The damage would be catastrophic. You have to be able to trust your data. And the final pillar is availability. You know, security isn't just about keeping the bad guys out, it's also about making sure the good guys can get in. Availability just means that when you're an authorized user, you can get to your data whenever you need it. What good is a fortress if the rightful king can't even get through his own front gate?
Okay, so we know what we're protecting: confidentiality, integrity, and availability. The big question now is, how do we actually do it? So let's talk about building the walls and gates of our fortress, the actual control measures. We've got a whole toolbox of defenses we can use. Some of the biggest are access control, which is all about deciding who gets in, and encryption, which is basically scrambling the data itself. There are more advanced things too, but for our tour, we're going to focus on the two heavy hitters: encryption and access control. So, a core defense is encryption. This is essentially the fortress's secret code. It takes sensitive data and scrambles it into a format that's completely unreadable. So even if an attacker manages to steal a file, all they get is a bunch of gibberish, unless they have the secret key. This is absolutely critical. But who manages all of this? This is where a super important person comes in, the database administrator, or DBA. The DBA is the guardian of the fortress. They're the central authority, the one who holds the master keys. They're responsible for creating accounts, handing out permissions, and, just as important, taking them away. And that big responsibility, granting and revoking privileges, that brings us right to the heart of day-to-day security: access control. This is the system that decides who gets the keys to which rooms inside our fortress. So how do you decide? Right? You can't just give everyone a master key. That would be chaos. You need a system, a philosophy for how you're going to hand out those keys. And it turns out there are a couple of major ways to think about this. On one side, you have what's called discretionary access control, or DAC. This one is super flexible. If you own a piece of data, you can decide to grant access to other people. It's kind of like being able to make a copy of your house key for a friend. Then, on the complete opposite end, you have mandatory access control, or MAC. This is super rigid. Access is controlled by a central, system-wide policy. Think of a guard who only hands out keys based on a master rulebook that absolutely no one can change. Now, while DAC and MAC are really important ideas, what most organizations actually use today is a more practical approach that kind of combines the best of both worlds. It's called role-based access control, or RBAC. And the core idea here is so simple, but it's incredibly powerful. Instead of trying to manage permissions for every single person, which would be a total nightmare in a big company, you give permissions to roles. You figure out what a sales rep needs to see or what a marketing manager can do,
and then you just assign people to those roles.
It works in this really clean three-step loop. First, the DBA creates all the roles the organization needs. Second, they give the right permissions to each of those roles based on what their job is. And third, they just pop individual users into the correct roles. It's so much cleaner and easier to manage.
Let's look at a quick example of how this works. First, you see the command create role manager. Boom, we've just made a manager role. Next, we grant that role the power to select or read and update the customer data. Finally, we grant the manager role to a user named Avi. And just like that, Avi has all the manager permissions, and we never had to give them to him directly. Okay, so we've gone through all this technical stuff. Access control, roles, permissions. But how does it all build to something bigger? Well, this isn't just about protecting a company's data. It leads directly to something that's deeply personal for all of us, protecting our privacy. And this is the key connection right here. There's a core security idea called the principle of least privilege, which just means you only give people access to the absolute minimum data they need to do their job. When you build a system that way, you automatically, inherently protect the privacy of every single person in that database. And that really brings us to the most important takeaway of this entire explainer. You just can't have privacy without security. Security provides the walls, the gates, the rules. It's the technical muscle that actually makes the promises of privacy a reality. It is the foundation. So all these systems give us a powerful framework for protecting our data. But as we all see in the news practically every day, attackers are getting smarter and are constantly finding new ways in. It leaves us with a pretty critical question to think about. In this escalating digital arms race, are the fortresses we're building actually strong enough?